Thanks for, first of all, inviting me to speak with you today. A little bit about me before I dive into the topic. My name is Milan Jovanović. I'm a software architect, Microsoft MVP, and an avid content creator. You can find me on my YouTube channel, where I post videos almost every day. And I also share pretty insightful content about software engineering on LinkedIn and Twitter. So if you want to connect with me, this is where you can find me. Today's topic is going to be about modular monoliths. I'm going to discuss how you can build one and what are some of the lessons that me and my team learned while building a modular monolith on our project for the past few years. So this is our agenda for today on a high level. I'll be talking first about what is a monolith. Then I'm going to discuss what are microservices. I'm going to do a high-level comparison between the two. And then we're going to dive into modular monolith. What are the challenges of building a modular monolith? And what are some of the lessons that we unfortunately had to learn the hard way? But I'm hoping that with my today's talk, you won't run into these same mistakes as we did. So without further ado, behold the majestic monolith. So what we say when we try to describe a monolith application is we have one application for the entire system, or to be more precise, we have one deployment unit for the entire system. Now, these days, it's considered a little bit old-fashioned. And when it comes to scalability, there are some concerns, which I'm going to discuss a bit later on when I'm doing the comparison with microservices. And on the other end of the spectrum, we have the microservices architecture, where many individual services come together to form the complete system. It's cutting edge and cool. Everybody wants to be working with microservices these days. And in theory, they should have infinite scalability, although in reality, it's a little bit different. Now, let's try to do a comparison between monoliths and microservices on some key points. First off, when it comes to deployment artifacts or deployment units, with a monolith, you only have one deployment unit. With microservices, this is a little bit more complicated because you end up having one deployment unit for each of your services. So the deployment process is significantly more complicated with microservices than it is with the monolith architecture. When it comes to communication, in a monolith, you have simple method calls. And in microservices, you have these complex and unstable network calls. And if you think about the fallacies of distributed computing, it should be obvious why network calls aren't really ideal. When it comes to scalability, the easiest way to scale a monolith is vertically. You just add more resources to the server running your monolith. You can scale it horizontally by creating multiple instances of your monolith, but this is not really resource efficient because you are scaling your entire monolith where there's typically just a part of your system that is running into some scaling issues, and you can't scale that individually, so you're forced to scale the entire monolith. With microservices, this is easy because you can both scale them vertically and horizontally. And when you're scaling horizontally, you're only affecting the one service, so your resource utilization is going to be much better. With a monolith, you only have one database. Typically, in our world, this is going to be SQL, some SQL database, preferably SQL Server or Postgres. And with microservices, you have one database per microservice, although there are situations when people use even more than that. So monoliths enjoy the benefits of atomic transactions when it comes to working with the database. And in microservices, you have to learn to live with eventual consistency. This is where your system eventually converges into some consistent state whenever a change is triggered in one of your services. What about teamwork? So if you're working with a monolith, it's going to be difficult to scale that application to a large team This is because everybody would be working in the same code base, conflicts would be common, and it's not really easy to split responsibilities between teams. Whereas with microservices, you can make your teams responsible for a few services each, and then teams won't be conflicting with each other and everybody can work on their own service. So having said that, I hope you have a little bit clearer picture of what are some of the key differences between monoliths and microservices. And here's a nice quote from Martin Fowler, where he says, "You shouldn't start a new project with microservices, even if you're sure that your application will be big enough to make it worthwhile." Now, we're going to try to remember this quote as we go through our presentation today, because I'm going to be unpacking the important points of why he actually said this and what did he mean by you shouldn't really start a new project with microservices. So what if we could have the best of both worlds of what I just talked about? So we get the physical architecture of a monolith. So one deployment unit, one database, atomic transactions. We get the logical architecture of microservices. So it's easy. Our system is split into individual components that teams can work on separately without conflicting with each other. And we could also have this bonus feature of being able to move into microservices whenever we want to. So this might seem like me trying to imagine something. How is this even possible? But it really is possible. And it's called a modular monolith. So this is the architecture that I'm going to describe to you today. And by the end, you'll be able to understand what a modular monolith is and why this is an excellent architecture for when you have a complicated system, but you don't necessarily need the extreme complexity of microservices. So what is actually a modular monolith? I'm going to give you this boring definition. So a modular monolith is a software design approach in which a monolith is designed with an emphasis on interchangeable and potentially reusable modules. So you're probably as confused as I am when you read a definition like this. So let's try something else. A modular monolith is an explicit name for a monolith system designed in a modular way. And the definition for the word modular, because there's a lot of emphasis on modular, it means consisting of separate parts, this is important, that when combined together form a complete whole. So the entire idea behind a modular monolith is that you have these parts of your system, which are called modules. They are each responsible for a subset of the features of that monolith. And then you put these modules together and you get your complete monolith system. So let's try to unpack this and see what I actually mean. So here's a C4 diagram of a typical monolith system. There's one database and one application, and your application is just a single component, let's say an ASP.NET Core Web API. Now, if you transition this system into the microservices architecture, let's say that we split it into 4 separate services. So we end up with the catalog service, the orders service, the customers, and collaboration services. So now, instead of everything being inside of a monolith, you have 4 services, each one being a separate web API, let's say. Each one has its own database, and each service is responsible for a subset of the features of the entire monolith. So if we try to combine kind of these two, like I discussed, so we want the physical architecture of a monolith, that we have one deployment unit, and we want to get this logical separation that we have in microservices. So this is what that would look like in a modular monolith system. So what were services in the microservices architecture before are now modules in our modular monolith. So we have these 4 distinct components which represent our modules in the monolith application. They are all compiled and deployed together in a single deployment unit, and they all operate on the same database underneath, which in this case is, in this example, it's Postgres. So now that you have this diagram that you can relate to the modular monolith, what are some of the challenges of building a modular monolith system? So first off, you need to define your modules and bounded context. So this is important. Then you need to figure out how you're going to implement communication between modules. And lastly, you need to solve the data independence and isolation between your modules. So let's start off with the first point, which is defining your modules. So modules are supposed to represent cohesive sets of functionalities. If you recall from our example before, we had 4 distinct modules, and you could assign which features belong to each of those modules. So another important concept in defining a module is the term bounded context, which comes from the book Domain-Driven Design, which was written by Eric Evans. And what a bounded context is, by definition, is a boundary within a domain where a particular domain model applies. So what this means in practice is you could have, let's say, a customer being part of your domain model, and that customer could belong to multiple bounded contexts in your system. So that would be the same customer, only applied in different bounded contexts with the specific meaning that is relevant to that bounded context. And also, you can treat each module as a separate application, meaning that it should be isolated from the other modules and be able to function independently of the other modules. Now, having said that your module should be independent, it means that you need to choose a top-level architecture for your modules. So here you have a lot of freedom. You could use a typical n-layer architecture like this one here with 3 layers with the UI, business, and database layers. You could also choose a clean architecture for your modules. And the one that's really popular these days is the vertical slice architecture, where you are grouping your features into what's called vertical slices. And if you think about it, it's pretty similar to the idea behind the modular monolith, where you are grouping your features into modules. This is one level below. Let's say you're grouping individual endpoints in your application and everything related to the functioning of that endpoint. So a nice example of a modular monolith, and this one also includes domain-driven design, you can find in this repository. I suggest that you take a look at it because I think the implementation is really nice and you'll be able to learn a lot from it. So not just modular monoliths, but also how to use domain-driven design, how to apply event sourcing to a system, and so on. So the next part, after figuring out what your modules are, is how they're going to communicate between each other. So each of your modules is supposed to expose a public API that other modules can call. Then no references are allowed to other modules. So if you recall, you're working in a monolith system and nothing is really preventing you from referencing the class library of some other module. But you really shouldn't be doing this because you would be breaking your architecture. So you're only allowed to reference whatever is the public API of other modules. The idea behind this is to hide the implementation details of your modules. And a good way to achieve this is by using the internal keyword in C# to hide the implementation within your separate assemblies. Now, I'm going to show you two approaches for how you can practically implement communication between modules. So option one is using method calls. So let's say the order module, or rather the order component inside the module, wants to fetch something from the catalog module. It's going to perform a method call to the catalog module and fetch whatever it needs. So the benefit of this approach is this is fast because this is an in-memory call. The problem, or the slight problem, is it introduces runtime coupling between your modules. So typically, you're going to expose your public API, let's say from the catalog module in this example, as an interface. And at runtime, you're going to wire up dependency injection to replace that interface with a concrete implementation. So even though you are depending on the interface, at runtime, you are depending on the concrete implementation, and this introduces coupling. If you ever wish to separate those modules out, you'll have to provide a different implementation. Option two is to use messaging. So the benefit of this approach is that it is asynchronous, whereas method calls are synchronous or blocking. It's possible to implement remote procedure-like calls by sending request and response messages. A good library that I use for something like this is called Mass Transit. I suggest you take a look at it because it's pretty powerful with .NET. So the idea is that you define interfaces that are going to represent your message contracts. And these are the messages that your modules are allowed to send between each other to share data, trigger actions, and so on. How you can share them is either a shared library, or you can use NuGet packages to distribute the libraries containing the contracts for your messages. The benefit of this approach is it is completely decoupled. So if you ever decide to pull out one of your modules into a separate service and you are using messaging, everything will continue to function the same as before. So to compare it with the previous approach, instead of doing a method call to fetch something from another module, I would send a message. The other module would subscribe to that message and then send a response back, which I would be listening to. So the added benefit of using messaging and because of the fact that it is decoupled is it is easy to extract modules into separate services. So if I were to take, for example, the order module and pull it into its own service, because I'm using messaging, everything will continue to function the same as before. And the third challenge that I mentioned was solving data independence between modules. So every module is responsible for its own data. This is very critical. Querying data directly from other modules is not allowed because this is going to introduce coupling between your modules. So you should not be doing this. And then there are different levels of data isolation between modules. So on the first level, you would have no isolation, meaning everything is in a single database. There is no distinction between which data or which tables belong to which module. And this is the not recommended approach. So you should at least be doing logical separation, which is you're still using the same database for your modules, but you're using a different schema. So in our example, we would have the orders, catalog, customers, and collaboration schemas. And now it's pretty clear which tables belong to which module. Foreign keys, you could be doing them between the tables of different modules, although it's not suggested because foreign keys introduce coupling. So if you ever decide to pull out some of the tables from one of the modules into a separate database, your foreign keys are going to break. So if this kind of isn't enough for your needs, you can take it a level further, where instead of having everything in the same database but different schemas, now you have different databases for each of your modules. So here I have the catalog, orders, and customers databases, and I'm still using the same database type. Let's say this is all Postgres. And lastly, what I can do is I can take each module, give it its own database, and I can even give it a different type of database. So I could mix and match between SQL, graph databases, document, and column store. If this is something that is valuable to me to be able to represent data in different formats and make the most of each database type in each specific module. And lastly, I'm going to share what are some of the important lessons that we learned along the way while building a modular monolith. So the first lesson that I want to share with you is you should spend a lot more time defining module boundaries because it's going to pay off in the long run. And this is where the advantage of working with a monolith really shines versus if you start with microservices, because it's not really clear from the start of the project what your module boundaries are going to be. So in a monolith system, you have the freedom and flexibility to make your modules as big or as small as possible without really having to worry about the consequences of that. Whereas if you started with microservices and you kind of missed the boundaries between your services, and now you need to merge services or move parts of your system from one microservice to another, you're going to have a really hard time to migrate all of that. And in a modular or in a monolith system, and even better in a modular monolith system, this is really easy to do. So spend as much time as possible defining what your module boundaries are, because it's going to be much easier to continue developing the project as it becomes more mature. The second pain point that we encountered is what I call chatty modules. The same applies to chatty microservices. And the pain point here is, let's say you have two modules that are constantly sending messages to each other. This could be method calls. So these modules are consistently calling the public API of that modules, or they could be exchanging messages through a message broker. The problem is that this introduces a lot of coupling, for one. Second, it's probably not optimal from a performance standpoint, because there's a reason that they are constantly sending messages. They're chatty, probably because one of the modules constantly requires data from the other module. So if you notice that something like that is happening in your system, it's probably a good sign that you should consider merging these modules together, making them one module so that they share the same data underneath and they no longer require this chattiness between the modules. This is kind of tied with the first point of defining your module boundaries. So in our case, when we ran into the issue of chatty modules, it was more of a problem of incorrectly defined module boundaries, and we solved it by merging these modules together. Now, another pain point is how you are going to share data between modules. If you allow your modules to call each other to fetch the data that is missing, you run into the risk of ending up with chatty modules. So a better approach would probably be to somehow share this data once and then be able to reuse it consistently. So two approaches, two solutions to this problem. When something happens in one of the modules, you can raise an event. This can be an in-memory event or a message to the message broker. Then your other modules can subscribe to this event and synchronize the data that is required, that was the state change that triggered this event. And another approach can be you query the data once from the other module and you cache it locally, either in memory, a RAM memory, I mean, or you can use a distributed database like Redis and cache the data there, and then be able to reuse it for as long as possible. And lastly, you should be really careful if you start introducing eventual consistency into your modular monolith system, because at surface level, it's really good. It allows your modules to be developed independently of each other. Whenever some state change occurs in one of the modules, you just raise an event and let the other modules deal with it. Eventually, your system is going to converge into a consistent state. But the problem is exactly that, eventual consistency. You need to take into account what are the implications of eventual consistency on your user interface and your user experience. One issue that we ran into was we had data that was being presented from two different modules, and these modules were eventually consistent. So the user interface was performing an update on the data of one module, and that was being immediately persisted in the database. And then you would see the lag on the user interface because the other module was eventually consistent. So if after a few seconds, for example, you refresh the page, everything is going to be fine, but the user doesn't really know this, and they shouldn't have to. So they ran into a problem. So a couple solutions how you can solve this. You could fake the data on the user interface. So if the initial transaction with the first module completes, you can do an eager update of the data from the second module just on the user interface, so that it seems to the user like everything completed just fine. And in the background, you can take care of eventually being consistent with your state. You could also, at the point in time when the change is propagated to your other module, send a notification, maybe via something like Signal R to the user interface to update the state, so that there's at least minimal latency, even though you are eventually consistent. And if none of that is possible, then you probably need to consider how you're going to be immediately consistent. So one straightforward solution is merging your modules, putting them into a single module, and then enjoying the benefits of transactions and immediate consistency. Or you could be brave and try to implement something like two-phase commit or a distributed transaction, but I really don't recommend going down that route. So I hope these lessons were useful. We learned a lot trying to solve all of these problems, and we didn't run into them all at once. It was kind of a process over the span of a few years. So when some of these problems popped up, we figured out a way for how we're going to solve this. So with this, I conclude my talk, and we have some time for questions from the audience.
Yeah, thank you so much, Milan mate. It was a nice presentation. So if there is any question, then you can just type on the QA panel, or you can just unmute. I have given you the permission. You can ask to the Milan mate. So about the question which you want to ask. So before that, I want to ask about the question. That means right now we are more going with the microservices, right? So how do you find the companies who is still using the monolith application and wants to migrate their application to the monolith? So what are the complexity that occurs?
So going from a monolith to microservices, is that your question?
Yeah.
Okay, so a great approach, and I think one that a lot of companies are starting to embrace, is moving from a monolith into a modular monolith and then into microservices. Because a modular monolith and a monolith is still a monolith system. You can take your time and define your modules correctly, apply all of what I just talked about today to make them independent and isolated from other modules. And then it becomes really easy to take a single module and move it into its own microservice.
Okay, mate. Thank you for that. So we have two attendees, Chandan, Gimirezi, and Soros. So if you want to ask something to our speaker, Milan, you can just unmute yourself and you can raise your query.
Thank you, Joy. Milan, actually, I don't have any questions for you because your presentation was well formatted and it was like giving us a top knowledge for us. But I would like to thank you personally for sharing your experiences with us, because me and Chandra, we are on the same team and we have a application that we have been working since 5 years, and we started it in a monolith way, and in the midway we are just in the midway now, and after 5 years we are planning to switch it to the microservices. But a major takeaway from your presentation that I took today was that we should not hurry to switch to microservices, because there is a modular monolith architecture in between, in which we can switch our monolith application easily, and we can just practice some features or some of the architectural things in that, and after that we can go to microservices. So Milan, thank you for sharing your experience, and yeah, thank you, Joy, for organizing this platform. We have learned very it was a nice experience for me personally. Thank you once again, Milan and Joy.
Yeah, very welcome. I think that's going to be a nice strategy for you, because it's really difficult to nail the scope of your microservice on the first try. And with microservices, it's kind of complicated because now you're working in a distributed system, whereas with a modular monolith, you still don't have the complexities of a distributed system.
Yeah, very true, because we are still struggling in we were planning to move to the microservices, and we are struggling how to separate our application, like what are the paths, what are the processes, or what are the features that we want to start differently or make a different entity and merge them. So we are struggling in that phase, but yeah, mate, thank you very much. Now we should plan to go for a modular monolith first. And after that, yeah, quite a lot, after practicing some of the architectural practice in that part, we can go, hopefully we can go to microservices later.
Yep. Awesome.
Awesome. Thanks.
Okay, thank you so much for that one. Just I want to ask some question related with the career, right? So Miss, what is your point on the career point of view? And can you share some of your experience that means within this 6 year, how did you grow in the IT industry? So can you share some of your experience?
Okay, so I started in a small IT company here in Serbia, straight out of college. And for the first few years, my focus was on learning everything that's possible. I was mostly working in small monolith systems for the first, let's say, 2 years. And then I jumped into .NET Core and a really large microservice system with like 50 independent services. I was personally responsible for one of those services and then integrating with a few other. So then my focus switched from monolith systems into distributed systems and then trying to learn everything that's possible. At the time, I also got exposed to domain-driven design, so I started studying that. And after that, it was just my natural curiosity of wanting to learn more about software architecture, and then also having the chance to apply the things I learned at my job.
Okay, that was nice. And how is the IT industry in there? So, Miss, how do you work? So you also do outsourcing things, or there is more about the internal development?
So there's access to everything. I'd say the most common in Serbia is still outsourcing and consulting companies. We also have a Microsoft office in Serbia, so there's big tech present. And recently, there have been a lot of startups that have been emerging. Some of them that have become really big. One of those that I can think of is Clockify, which is like a tool for logging your time. I think it's if you've heard of Toggle and similar tools, it's a big competitor of theirs.
Okay, thank you so much. And my last question is that means right now I'm listening a lot about the AI, right? AI products, which is not relevant with this topic, but I want to know from you that what is your point of view on the AI, just like making the AI product, right? And using just like the right tools and stack. So how means, so what's your point on that one? The future is on the AI product, or it is more about the ongoing product which we are doing on the IT industry?
So I think the future is definitely in AI, especially given the speed of how everything has been developing in recent years. In the past 6 months, we got ChatGPT, then GPT-4, and then other companies are coming out with their models. I think it's a really wonderful time to be exposed to AI and to be working as an engineer. And I don't think we should fear being replaced by artificial intelligence. I think that it's going to make us better at our job. So these tools that have been coming up, like GitHub Copilot, if you've tried it out, they're really nice for getting you started on something, or if you are stuck on some boilerplate feature, it can help you kind of speed you up, and then you can take it from there to implement the more complicated features. So I think AI is going to help in not having to write as much boilerplate as we currently do, and allowing us to focus on what really matters, and that is delivering value to our customers.
Yeah, that's right. So means the right direction, means with less effort, less time, more productivity. That's right. So yeah, so I think we are at the end of our webinar. So it's been around 45 minutes. Yeah, that was allotted the time. Thank you so much to deliver on the time. And I want to thank you for all the participants for coming on this tech webinar series 53. And thank you Chandan, Gimireji and Saurabhji for your participation also. And thank you Milan Mate for your valuable time for this series 53. And I want to thank you to our supporters also, Microsoft, Media Partner, Living with ICT, And yeah, and all the audience from the Facebook who is watching us. We will see you on our next tech webinar series 54 might be on the Agile we are planning to do. Please join on that one and keep supporting tech webinar as well as the community. Thank you so much. Have a nice day. Thank you.
Have a nice day.
Have a nice day.